Our next lesson is called Graphs Can Solve Equations 2, Day 2. So I'd like you to start by completing the opening exercise. In number 1, the functions y equals f of x and y equals g of x are graphed below. Determine and state all values for x for which f of x equals g of x. And then in number 2, the graphs of f of x, a function that involves taking an absolute value, and g of x, a linear function, are shown to the right. So it's kind of down towards the bottom corner. Both functions are defined over all real values for x. Tammy concluded that the equation f of x equals g of x has no solution. Do you agree or disagree? Explain your reasoning. So at this time, I'd like you to pause the video and try the opening exercise questions on your own, and then resume the video to go over your answers. Okay, now that you had a chance to do this, let's look at number 1. We had y equals f of x and y equals g of x, two different functions. We want to determine and state all values of x for which f of x equals g of x. So a reminder and a review of the lesson prior to this one. You want to find the intersection points, but then only use the x values. Okay, so when we look at the graph, I see the two intersection points. I see -5, 2, and then I see 1, 2. I'm going to take the x values only from those, and that's going to be -5 and then 1. For question 2, do you agree or disagree? I actually disagree because the two functions may cross at an x value greater than 10, which I cannot see on this graph. So if it's an absolute value function, these should be going up still. And then the linear function should be going there. And that means it could potentially cross somewhere up in here, but right now I can't see that because I don't see that part of the graph. So now we're going to complete an example together. Solve the equation graphically. So our equation is negative, then absolute value of x minus 3.5, then plus 4, equals negative 0.25x minus 1. So this is our second day of this lesson. We know to start that we have to go ahead and split these into two different functions. We'll take the left-hand side to create the first function. F of x equals negative, then x minus 3.5 plus 4. And then the second function we'll call g of x. We don't want them to have the same name. And that I'm going to change from negative 0.25x to negative 1/4 x minus 1. Just because that way it's going to be easier when we go to graph it with a slope. So it says graph the function in an appropriate viewing window and show your work. So the first one, f of x, we definitely want to go straight to the calculator. And we're going to get a table of values, f of x on this side, x over on the input side. And we're going to go take a look at what the graphing calculator looks like. So we'll go to the y equals screen and we're going to type in what we see. We're going to see negative. Then we're going to go to math, over to number, and we're going to pick number 1, which is absolute value. In there, we're going to do x minus 3.5. Then arrow over to go outside of the absolute value and then hit plus 4. We can hit enter. And then when we look at the graph, this is what it's looking like. So we want to take a look at the table of values by hitting second and graph. And we'll work our way up towards 0 and kind of see what's going on. And we can start to see the turn here. So we have 0, 0.5, we have 1, 1.5, and before that you can see we have -1, -0.5, and we're kind of looking for that symmetry to pop up here to show us a graph that will tell us information enough to be able to graph the picture. So when we look at this table, we're definitely going to have to plot some half points. But we're also going to see that we can't find exactly where it's hitting. We don't have a number that's kind of alone in the middle. So we want to take a look at that when we start moving forward. You see, you can here between 3.5, 3.5, it's the same value. Between 3 and 4 somewhere, it must hit its peak. So I'm going to talk to you today about how you can change the values in the table to help you better figure this out. So you can change the setup of the table by hitting the second key and then window, and that takes you to table setup. Here you can start wherever you want. For example, I could go to 0. And then if you go down to the change in the table, it's a little triangle, then TBL, you can change what the table goes by. So what I'd like our table to go by is actually 0.5. So now when I go back and look at the table by hitting second graph, and I go down to those points we said we weren't sure where it hits, now we can see that it bounces or turns at 3.54. And that will help us graph more accordingly. So we'll go back and we'll write down the values that make the most sense for our table. We definitely want to have the 3.5, 4, and then a little bit of either side so we can see where it starts to change direction. We'll make a couple notes here now that we're back on this screen. The first one I want to do is I want to write change table. And you're going to do that by going to table setup, which you do have to use the second key to get to. And I want you to make your change in the table go by 0.5. If we do that, we can see the turning point. So now I can put 0.5, 1, 1.5, 2, 2.5, 3, 3.5. And then we were able to find that critical point where it turned 3.5, 4. And then it starts to go down again. So we'll have 4, 3.5, and 5, 2.5. And again, we can kind of see here where it turns. So now we'll go to the graph and we'll graph this to the best of our ability. We'll go to 0.5, which is halfway between 0 and 1. Notice they marked every 2 blocks, so just be really careful of that. 1, 1.5. 2, 2.5, 3, 3.5. Then at 3.5, we're hitting 4, and then we're coming back down to 4, 3.5, 5, 2.5. And then you can kind of see the slope on each side, but you also have a straight edge or ruler that you can use to connect them. So you want to do that. Grab a straight edge if you need to. And then we'll do the same thing on the other side to make our full picture here. And then we'll label this y equals f of x. So that's our first one. Now next, we're going to go to g of x. And we can give ourselves a table of values here, but we can also use slope and y-intercept. So we could write down that the slope is negative 1/4, which means you're going down 1 to the right 4, starting at a value of -1 or 0, -1. Or we could also go to our graphing calculator and get a table of values similar to what we did before. So I'm going to choose to show you graphing using -1 and then going down 1 to the right 4, down 1 to the right 4. If I want points in the other direction, I would go up 1 to the left 4, up 1 to the left 4. Then I will connect them to make my line, arrows on both ends, and I will label this one y equals g of x. Now, if I were to go to the graphing calculator, I could write down these same values, 0, -1, 4, -2, 8, -3, and 12, -4. And then I would want to take a look at where these are intersecting. And this is where we're introducing what really is the main idea of today, is using your technology to help you. When we try to see where these are intersecting, here's the first spot. I cannot tell the exact identification of that point. And then the other problem is these are definitely going to cross, but they're not from what I can see. So I need to figure out where they're going to cross off the graph here. So once again, I want to talk about this whole changing of the calculator to benefit us. I'd like you to go highlight here the appropriate viewing window. And we're going to comment change window. And then I'm going to show you how to do that on the graphing calculator. So we'll go to the y equals screen and we're going to type in our second equation, negative, then alpha y equals to get to our fractions. And we're going to do 1/4. Then arrow over and type our x and then -1. So we can look at the graph and see that we have a similar picture. And even on this graph, you can see we can't tell the other crossing point. And we can look at the table of values here, as I said, looking at x and y2 to get the values that we had from before. So what we want to do is go back to the graph, and we've got to see this window a little bit wider. I need to see past 10 so that I can see where they're crossing. So I'm going to change the window this time. And I'm just going to do that by hitting the window button. My x min is -10 is totally fine, but I'm going to change my x max maybe to 12 and see if I can see where they're going to cross. So now when I go back to the graph, that second intersection point is on there. So because, one, I can't see the exact location of the first one, and two, now that I see this one, I can't tell that exact location either, we want to use on the calculator the intersection function. So we're going to go to second, calculate, and we want to find out where these things are intersecting. So I'm going to hit 5. Now, for me, it's going to want me to do left bound and right bound. You just move your cursor to the left of the first one. You'll have a little blinking cursor and you'll hit enter for your first curve. Then go to the right of the intersection point and hit enter. And then you should get your intersection point. You might have to hit enter a third time in order to do your guess. But you can see on my screen that it says the intersection is -1.2 and -0.7. So we're going to write that down back in our notes. So the first intersection point was -1.2 and -0.7. And then we know there's a second intersection point, so let's go do that same thing again on our graphing calculator. So we are going to hit second, trace to get to calculate, and we're going to hit intersection again. This time we're going to go all the way over towards the other point of intersection, and I'm going to stay to the left of it and hit enter. I'm then going to go to the right of it and hit enter. And then you might have to again hit enter, but you can see here my intersection point is 11.3 repeating, which would be 11 and 1/3. We don't write repeating decimals. And then -3.83 repeating, which if you change on your graphing calculator will be -3 and 5/6. So we're going to go back and write those down. Our other one is 11 and 1/3 and -3 and 5/6. And then underneath that, I want us to put a quick little note of what we did to get this. We use the intersection on the graphing calculator. And that was by hitting second. That gets you to calculate, which came from originally the trace button. And then you are picking number 5, intersection. And then that will give you your points. You just have to do it twice. And I already demonstrated how that would look. So now that we actually know the answers and we can see technology is going to be our best friend here, we want to verify that the x-coordinates of the intersection points are actually solutions to the equation. So we'll start with writing it once and checking our first coordinate, and then we're going to have to do a second check to check our second coordinate. So we start out by writing the original equation. I already typed that there for you, so you can just start filling in. So we're going to have negative, and then in the first one, remember, we're only concerned with the x values. So let's go up and make sure we notice that. We really care about the x values. So we think our solutions are x equals negative 1.2. We're going to check that one. And we think x equals 11 1/3. So for this first function on the left, we've got negative, and then we've got in parentheses, negative 1.2 minus 3.5, not in parentheses, in absolute value, and then plus 4 on the outside of that. While on the other side, we want to have that negative 0.25, then times x, which we have as negative 1.2, and then minus 1. So we'll start working our way through this. On the left, we would have negative, and then in parentheses, again, not in parentheses, absolute value, we would have negative 4.7. Then on the outside, plus 4. On the other side, we would have 0.3 minus 1. The absolute value of negative 4.7 is 4.7. This negative is just coming along for the ride from being out in front. On this side, we have negative 0.7. And then when we do negative 4.7 plus 4, we get negative 0.7, and we see that both sides match. So 1.2 is definitely a solution. And then we'll do it again, but with our second answer. So we already have it written. We're just going to start substituting. So I'm going to put in 11 1/3 minus 3.5 plus 4. Then on the other side, negative 0.25 times 11 1/3 minus 1. So over here, I changed it all to fractions and got 47/6. On the other side, again, I changed it to fractions and got negative 17/6. Then here we would have negative 47/6 because the absolute value of 47/6 is 47/6 and the negative is out in front. On this side, we would get negative 23/3. So when we do this, we're going to end up with negative 3 5/6 on this side and negative 3 5/6 on this side. So it also checks. So let's make a little comment here that verify, remember, means to check. And as you can see, we need 2 of them, 1 for each of our solutions. So then lastly, are the x-coordinates of your points of intersection the same as your solution to the equation? So we'll say yes. When using the intersection function, on the calculator, you see it is x equals negative 1.2 and 11 1/3. And they check in the equation. So again, today was all about seeing how the calculator may have to be used in order to even answer this. If you cannot identify the exact coordinates where they cross, or it's not even in the viewing window of what you graphed, you are going to rely on your graphing calculator by not only changing the table if you have to, but more importantly, changing the window with the window key, making sure you can see more of the picture. You can change the X max or min at any point. Same thing with the Y values. You can change the Y minimum and maximum as well. And that concludes our lesson on Graphs Can Solve Equations 2, Day 2.